Welcome back. Problem 3, section 3.5, if from web work. The function is fx equals 3x over x squared minus 25. There are a bunch of questions, but this is primarily about curve sketching. So I want to utilize this example for us to see how to sketch a curve. Okay. So we are going to go through the guidelines for sketching the curve. All right. So the very first thing is to find the domain. This is a rational function. It is not defined when the denominator is 0. Therefore, the denominator should not be 0. When you factor it, you get x minus 5, x plus 5 should not be 0. That means x should not be 5 and x should not be negative 5. So in my real number line, I have negative 5 to the left, 5 to the right. I remove those points. That's why there is that circle. Open circle means the points are removed. Once the points are removed, what is the domain? It's everything except these 2 points. That is, you have 3 pieces of the number line. Negative infinity to negative 5 open, union, negative 5 to 5 open, union, 5 to infinity, open. Open means endpoints are not included. All right. So that is your domain. The second item in your guideline, intercepts. How do I find y-intercept? You have to set x equals 0 in your function. Okay. Set x equals 0. So what do I get? 3, 0 above and 0 squared minus 25 below. So that gives me 3 times 0 is 0 above and negative 25 below. Now 0 divided by anything non-zero is 0. Alright. So y coordinate is 0. So x coordinate is 0, y coordinate is 0. That's the y-intercept. How do I find x-intercept? You have to set y equals 0. Y being the expression. Y being this expression. So I place that equal to 0. Because this is a fraction, I'll make a fraction over here. The 0 is written as 0 over 1. Cross multiply. You get 3x equals 0 times this. 0 times anything is 0. So 3x equals 0. Divide both sides by 3. X equals 0 over 3. 0 over 3 is 0. So what is the point here for the x-intercept? Well, y coordinate is 0. X coordinate is 0. Alright. There is no other x-intercept. So notice you have only one x-intercept, which is also the y-intercept. Okay. The next item in our guideline is symmetry. Symmetry exists for even function. Graphs are symmetric about the y-axis. That's what even functions do. Odd function, the graph is symmetric about the origin. That means 180-degree rotation will give me back the same picture. Okay, if I rotate this 180-degree, this half comes here, this half goes here. Perfect match. And the third kind of symmetry is periodic. So here is period P. The picture repeats. All right. So even, odd, periodic. Let's see whether my function is even. What does it mean to be even? F of negative x equals f of x. Write on fx. Wherever you see x, replace it by negative x. That's what f of negative x means. Negative 3x. Here, notice this is a square. So negative x squared gives me the same thing as x squared. So is negative 3x over x squared same as 3x over x squared minus 25? No. They are not equal. So f is not an even function. Because f is not an even function, the curve is not going to be symmetric about the y-axis. In other words, something like this will not happen. Left-right symmetry will not happen. Next question. Is f an odd function? That is f of negative x equals negative f of x? Wait a minute, we just calculated. Fx is this. F of negative x is this. Look, this is same as, see, when you have a negative above and positive below, it's an overall negative of the same expression. You understand? So this is nothing but negative of 3x over x. In other words, f of negative x, f of negative x is negative of fx. So this is an odd function. So the curve will be symmetric about the origin. So whatever we are drawing later, it will be symmetric about origin. That is, the rotation should help. Okay, should bring it back. Is your function periodic? Well, our function is rational. It is not periodic. Okay, rational functions are not periodic. What are periodic? For a function to be periodic, usually you need to have a trigonometric function, or it should be defined periodically. All right. So what's the next item after checking for symmetry? Asymptotes. Asymptotes come in three fashion. One is the horizontal asymptote, then you have the vertical asymptote, and then you have the possibility of a slant asymptote. Going through each piece, how do I encounter horizontal asymptotes? I have to take limits x approaching infinity or limit x approaching negative infinity. In this case, they both give me the same number, so I have used plus or minus infinity. This is a rational function. How do I find limits at infinities of a rational function? I take the highest power of x in the denominator and divide the numerator and denominator by this. So x squared is the highest power, so I'll divide 3x by x squared and x squared minus 25 by x squared. So numerator here, one of the x's cancel, you have 3 over x, right? Denominator division distributes, x squared over x squared is 1 minus 25 over x squared. Now you take limit going to infinity or negative infinity. Here this goes to 0, this goes to 0, and 1 is unaffected. So 0 over 1, which is a 0. So there is only one horizontal asymptote, y equals 0. What about vertical asymptote? Since fx is a rational function, we have to consider the factors of the denominator. Numerator and denominator do not have common factors. So, what are the factors of the denominator? Okay. So, this is my function. Okay. So, let's look at the function. It looks like this. So, that is equals, it's a fraction upstairs of 3x. Denominator is a difference of squares. So, it is x minus 5 times x plus 5. First, make sure there are no cancellations above and below. There are none. So, both these factors give me minus 5 and 5 as problematic numbers. Okay, they don't cancel. So, as x approaches either 5 or negative 5, the denominator is going to get so small that the limit is going to be an infinity. One kind of infinity, either plus infinity or negative infinity. We need to know the sign of the limits. Sign, am I going to get a positive infinity or negative infinity? That is the question. Okay, we are going to get some kind of infinity as x approaches 5 from the right, from the left. Negative 5 from the right, from the left. So you need to find these limits, okay? So how do we figure? Now, what you do is you look at the intervals. 0 you know is an x-intercept, so you need to include this as a cut point. Okay, we just want to see where f is positive or negative. So 0 is going to be a cut point because you could be positive one side, negative on the other, and so on. So what are my intervals? Negative infinity to negative 5, negative 5 to 0, 0 to 5, and 5 to infinity. Take a test point from each. Here I took negative 6, here I took negative 4, here I took 4, here I took 6. Now plug in these test points in your function. Where I see x, I plug in negative 6. Mind you, keep track of the signs and parentheses. I don't care about the entire value. I just want to know the sign. Upstairs is going to be a negative. Downstairs, this is going to be a positive 36 minus 25. So overall, a positive. So overall, the fraction is going to be a negative. Likewise, plug in negative 4. Upstairs is going to be negative. Downstairs, this is going to be a positive 16 minus 25. Well, 25 is bigger, so 16 minus 25 is going to be a negative number. Negative over negative, positive. Let's take 4. 3 times 4, upstairs is positive. Downstairs, 16 minus 25, again negative. Positive over negative, negative. 6, upstairs is positive. Downstairs, 36 minus 25, positive. Overall, positive. So this is very good. So what happens here is, why did I use these test points? You use test points for the entirety of the interval. So in the first interval, I'm going to get negative. Do you understand what that means? My function is downstairs, below the x-axis here. So if it's going to go to infinity, it cannot go up. It will go to negative infinity. All right. Here, what's happening here? In the second interval, negative 5 to 0, I am going to be positive. So I am going to be above the x-axis. If I'm going to be above the x-axis, then I'm not going to go below. I'm going to go positive infinity. Likewise, 0 to 5, I am negative. So this is negative. So I'm not going to go above, I'm going to go below. You see the arrow? Likewise, in the last one, I am positive. Right? In the last one, I am positive. So I'm above the x-axis. My curve will therefore go to positive infinity here instead of negative infinity. So that's how you determine the limits. Okay? So what does it say? X approaches negative 5 from the left gives me negative infinity. Okay? X approaching negative 5 from the right gives me positive infinity. All right? X approaching 5 from the left, I'm going to negative infinity. X approaching 5 from the right, I'm going to get positive infinity. So these are my limits. Okay, so that gives me vertical asymptotes at negative 5 and 5. So we now know, because these are going to some kind of infinity or the other, we have vertical asymptotes here. Okay, so slant asymptotes. Well, the limits to infinities are 0. In other words, towards the end, you're going to come to 0. Likewise here, you're going to come to 0. So you are not going to have any slant asymptotes. Slant, okay? So regardless, for a rational function, we expect slant asymptotes in cases when the numerator has degree 1 more than the degree of the denominator. But look, our numerator has degree 1 less. So we are not going to get slant asymptote here, okay? In my next video, I'll continue with intervals of increase or decrease. Until then, bye.